Hello, fellow problem solvers. So today we're going to be doing a problem from the Spring 2003 Tournament of Talents competition, Junior A levels, problem number 1. I suggest you try this problem out for a minimum of 15 minutes, ideally half an hour, but not more than an hour. If on the other hand you'd like to go along with us, I suggest you take 5 to 10 minutes and put your first ideas out on paper. So now, let's begin. So we have the first player of the game, Johnny here, writes down ABC. A quadratic equation of this form, ax squared plus bx plus c is 0, where a, b, c are positive integers. And then the other guy, what's his name, Pete, goes ahead and changes some of the pluses to minuses or keeps everything the same. Some of these two pluses, he either writes a minus or keeps the plus. And then we have to see if both of the roots of this equation, the changed equation, are integers. Then the first player, Johnny, wins. Else he loses. Now the first thing here, and now the question is like, can he choose ABC such that he wins? And so for me the first idea was, well, let's explore. So the roots are going to be x1 and x2. We know that they are, when you multiply them together, these two need to be integers. So when you multiply them together, you get what? You get minus b plus the discriminant over 2a times minus b minus the discriminant over 2a. This is by Vieta's rules, I think, yeah. We get b over a, if I am not mistaken. Or do we? Oh, b over 4a? Wait, what do we get? Oh, my bad, we get c over a. And then when we add them together, we get minus b over a. So the first thing to see is, if x1 and x2 are integers, then they're, when you multiply them and when you add them, you will get integers. So you will get that c is equal to ak, b is equal to al, and then what you're going to be having here is ax squared plus, what's this going to be, ak, or al x plus ak is 0, i.e. x squared plus lx plus k is 0. So we can probably assume without loss of generality that a has to be 1. And now from here, I invite you to take another 5 to 10 minutes and try to work with this, try to pose the problem further. And now the next thing is, okay, let's see, what do we have? X squared plus and minus bx plus minus c is 0. Well, the first thing to make sure that these are integers is the discriminant. It's going to be b squared minus 4c or b squared plus 4c. And then outside of the discriminant, we have minus b plus and minus the square root of the discriminant over 2. And now this, for me, I noticed something. The discriminant and the square root of the discriminant and b are going to be of the same parity. So if the discriminant is an integer, then this is going to be an integer, no matter how you choose the plus and minuses. So we need to find b and c such that both of these are squares. And now with this, if you haven't figured this out, I invite you to pause for another 5 to 10 minutes. And here's the next step. So what we get is that because b squared minus 4c is of the same parity as b, then we can write this as b minus 2x squared and b plus 2y squared for x and y that are positive integers. And now what we get is, when doing a bunch of algebra, we get this equation. And then this transforms into y times b plus y is equal to x times b minus x for some positive integers y, x, and b. And now what do I know about these numbers? Well, I know that y sort of needs to be less than x. It feels like that. It feels like here it actually felt like that to me. So let me try out the first two numbers that come to mind. Y is 1, x is 2, and what do we get? We get that b plus 1 is equal to 2 times b minus 2, i.e. b is equal to 5. And from here, what do we get? That c is equal to by plus y squared, which is 5 plus 1, which is 6. And now what is the discriminant? Well, in one case, it's going to be equal to b squared minus 4c, which is 25 minus 24, which is 1. And in the other case, it's going to be b squared plus 4c, which is 25 plus 24, which is 49, which is 7 squared. And now the write-up is quite quick, because in one case we have, if c is positive, we will get that we have minus b plus and minus, what do we have? The discriminant is going to be, so if it's plus c, then it's minus 4c plus and minus 1 over 2, i.e. b is 5, so it's plus and minus 5 plus and minus 1 over 2. That's what the roots are going to be in one case, like either a plus or a minus. And if it's negative c, then we're going to have minus b plus and minus 7 over 2, i.e. plus and minus 5 plus minus 7 over 2. We pick one of these, depending on if it's b or minus b, and we're done. Like in every one of these cases, these are integers. So the write-up's pretty straightforward, and I'll invite you to do it yourself. And as always, thanks for problem solving.